Vehicles today cost more than ever, and for many people, they're a very large investment. One of the first things they want to do is protect that investment, and they purchase custom floor mats for their specific vehicle. But did you ever wonder how they get those floor mats to fit so perfectly in your vehicle? Well, thanks to advances in 3D scanning and reverse engineering software, they can create floor mats that are a perfect fit for every vehicle. And in this demo, we're going to walk through and show the whole process of scanning and designing this floor mat you see here. So our first step in the process is to do the 3D scanning. And we are going to use the Creaform GoScan Spark 3D scanner. One of the advantages of the GoScan is it's extremely fast, it's handheld, so it's very portable, and it doesn't require any targets to do the scanning. You simply point and shoot and move around to capture it. So as you see here, we've turned it on. It's a structured light scanner. We've got some in-depth demos on this scanner if you'd like to see it. But you just try to get yourself somewhat perpendicular to the surfaces as you're scanning. And the beauty with it being handheld, that makes it very easy to articulate it around in the vehicle. And as you see here, vehicles in the footwell areas have lots of curves. You've got carpet, you've got plastic, you've got the seat, you've got metal, you've got a variety of surfaces, and the GoScan Spark does a great job on all of these different surface types. So again, you just continue to move around. The more perpendicular you are to a surface, just the better the data quality you get. And you just keep moving around till you get it. You can't overscan it, but you can see that's it. It's done, and that took about a minute to scan. All right, so now that the scanning is done, we're ready to get started on doing the actual CAD modeling. Because scan data is not CAD data, it's just a bunch of triangles or polygons. You really can't take this information and do any downstream applications with it. So we'll get into more of this as we go, but basically we're going to build surfaces from this, trim them all up, kind of stitch them all together, and then offset for our mat thickness. Now, we're using Design X for this example because of the level of surfacing and complexity that can be involved with designing floor mats. Design X is a really nice tool to do it. So we have it here. I don't really need to clean up the scan data at all. That's one of the really nice things about Design X. I don't have to fill holes. I don't have to smooth it. Not for this application. And again, floor mats can be quite complex. And there's a couple different types of floor mats. There's the kind of thick rubber type that just kind of sit more in the bottom, and then there's the vacuum form type that kind of go up the walls all the way around. So we're going to make one similar to that. So let's get started by kind of breaking this scan data up into what we call regions, and I'll explain here as we go. So I'm going to use this paintbrush tool, and what I'm going to do is paint the area of each kind of region, as we call it. And I'm going to stay away purposely from the corners where the radiuses are. I can make this tool bigger and smaller. It's basically a paintbrush, okay? And I'll say, hey, that looks good. We'll go into our region command. We'll insert a region, okay? And let's come over here. So what we're really doing is segmenting by color the different areas of this part, kind of the major surface areas. Okay, so let's come in here. Paint this area here. You don't have to be perfect. You get generally close. Okay, and I want to get as much down here as I can. And if I get too much, I can subtract it. Get a little bit more over here, a little here. That's good. Okay. And we'll insert that one. And the software will color code them. Now, the first one is green, and so it's the same color as my scan data here. This can all be defined by the user, but you still see the outline. Okay, so we'll get this one down here. Okay. Now, there's a command called auto segment that will. Oops, I didn't hit shift. I'll do that again. There is a command called auto segment, and for a lot of things it works great. But for this, because I want these kind of big general surface patches, a lot of times I would spend more time trying to dial it in to get what I want versus just, taking 5 minutes to do it this way. I just find it easier. Okay. And so, for example, up here, I'm going to get just up here. And again, if you kind of see, I'm just trying to get these flat areas on any surface. And this will make a whole lot of, hopefully make a whole lot of sense here shortly. Again, here. Okay, now this area here, probably going to break this up. We'll make this one, we'll make this one, and maybe this area one. Some of this is going to be a little bit of trial and error. Every car is different because these shapes are so organic. But the good news is we don't have to be super critical on the tolerances when we design these because we have the luxury of the carpet being there, and the carpet has some thickness and some give, so that definitely helps. And you kind of want a little bit of, I don't want to call it slop, but you definitely want a little bit of forgiveness in there because, the carpets, you got carpet and insulation, and they're not necessarily always installed the same, and there can be a little bit of variation from vehicle to vehicle. Okay, and then let's do this area here. All right, let's see what we have. So I want all the major surfaces there, here, 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 here. I think we're pretty good, okay? So those are our region groups, okay? So again, all we've done is color code the scan data. This keeps us from having to go in and break it all up. All right, so our next step is to do some modeling, some surface modeling. And we're going to do a couple different methods. The beauty of Design X is there's so many ways to do the same thing. Everybody has kind of their way of doing it. So I'll show a few different tools. We're going to use the Loft Wizard tool. We pick a region. Right now it's set to 8 sections. I don't probably need that many. Let's go 6. Let's pull it out. And I'll explain here what I'm doing in a second. Okay. So if you look, there's 6 planes that are going to get cut through that region. Now, obviously, these 2 sections on the outside are outside the region. It's going to kind of extend it out and approximate. And I want this to go beyond there because all these surface patches are going to need to be extended out. Okay. And then my smoothness here, I don't want that to be real smooth. Again, I'm working with carpet. I'm not trying to do Class A exterior surfacing here and to some high degree of accuracy. So let's hit the next button to the next step. And it's going to do some calculations based on what we've just set. And then we can pick the control points on these sketches, okay? So the more you have, the more it'll follow the curve. We don't want too many, but we want enough to represent the surface properly. And once it's done, you can see what we get. So we get this nice surface here. And we can do a deviation analysis at any time. Let's hit auto adjust here just so we can see. So I've set it to 1 millimeter. Everything in green is within a mil. That's more than enough tolerance for something like this. So that looks good. I'm not worried about out in these areas because this stuff's all going to get trimmed off later. Okay. So there's our first surface. You can see it goes out and beyond the area. And if it doesn't go enough, we've got trimming tools we're going to use in a little bit probably anyway. So same thing here. Let's pull it out. So some of this gets a little repetitious. Pull it up a little, pull it down. That looks good. That was 5 points is fine. I find with a lot of this, less is more. Okay. And again, we're still pretty good. Again, if we really want to pull it tight in these areas, we can. But I would not get too picky because then your mat would have like a lot of kind of undulations in it. You generally want it to be kind of smooth. Plus the mat will have give to it as well. Okay, let's do this bottom big surface here. Now you notice when we pick this one, it kind of picks the direction of the planes based on the region group. But if you don't like it, you can also pick a reference plane, and it'll go, for example, in this case, perpendicular to it. So that looks good. Again, we'll pull this out. And next step. And, again, if we want a few more points to make sure we're following that really well, we can do so. And what this accuracy analyzer lets me do is just compare these surfaces back to the mesh, and you can see as I highlight over, it shows me, how far away it is. So that's, again, for this, it's fine. All right, let's come over here now. I'm going to try a couple different things. Another command we use quite a bit is the mesh fit surface. This works great on some of these. It's kind of like I call it like vacuum forming. It sucks it down, and you can again adjust the how far you go beyond, just like the other commands. And I've got the control points set low, and I've got the deviation set high. And what that allows me to do is really get a nice kind of flat plane, which is really, again, all I'm looking for here. These areas are small. I don't have to be that particular with them. I'll take the defaults. And a lot of this is, once we start filleting all this later, a lot of this is going to get taken care of anyways. So we're just trying to have it meet that flat. Okay, let's do mesh fit here as well. Let's see how that looks. Okay, and now, so if we want to get, a little more control of this, and maybe we'll pull the smoothness back a little bit. Let's go to the next one. I'll show you. You've got some more control in here. So we can come in here and, pull these points around. Okay, we don't want that. Okay. Now, we're going out quite a bit. Let's come back. We don't need to go out so far. Okay, let's see here. Come up here, pull this in a little bit. The good and bad of mesh fit is you can really get some control on the surface, but you can see as you go beyond it, you start getting some crazy stuff. Now, most of that's going to get trimmed off anyway, so it's always a balance of trying to follow that surface shape. Let's go drop down to 6 and smooth it out a little bit. A lot of trial and error on some of these areas. I'd say that looks pretty good. And the other neat thing you can do is you can pull more curves and add them to it. Okay, let's see how that works. Okay, and then if we do our deviation from body, you can see in that area, which I'm most concerned about, it looks pretty good. Okay. And let's hide that surface. And let's try loft on this one. Go a little bit beyond both directions. And we can actually try multiple surface types on some of these, and later decide which one we like. Unlike solid modeling, it's not all part. I mean, the surfaces are just independent until we stitch them all together later. So if we want to surface it a couple different ways, we can do that. Okay. How are we looking over here? So we'll have this flat coming in. I think we should be okay. But again, the beauty is we can always try something else later. Okay, so let's pull this in. Again, we're going to go back to 4. Crank the smoothness up. And that should be good. All right, so let's take a look. We need, okay. So next what I want to do is I want to look and make sure all the surfaces intersect. So for example, right here, they may not. It's barely through. So I'm going to extend some of these out. And you can just pick an edge to extend, or you can kind of do all 4 sides. Okay, so that looks good. How'd all these look? That pokes through. This one probably could come out a little bit. Doesn't hurt to extend it. If you don't have it extended when you do some of your trims, you can have trouble. So bumping them up a little bit doesn't usually hurt unless it starts going crazy. When you extend it, if it really starts warping and curving, you got to be a little careful. Let's do this bottom here a little bit. Okay, I think we're good. All right. Okay, so let's go ahead and save this. I like to save right before I start doing a lot of heavy trimming and things like that, just to be safe. Okay, so now we're ready to start trimming it up. So we're going to go to the trim surface command. Let's start on an easy one so you can kind of understand how this works. So let's start with maybe this back one here. So we'll pick all the other surfaces that kind of made up to it. Those will be the tools. And then, of course, the target will be that. And that's the side we're going to keep. And where it starts to get a little tricky is sometimes you're going to have to pick multiple pieces. And it's not always easy to see. Okay. Now, you can do it multiple times, retrim it, but you got to be careful with that a little bit. So this is where it's going to start to get a little more complicated. So, for example, if we want to trim this, we want to pick that. This is not going to run into it. The bottom. I think that's it. This has already been trimmed. Target will be that. And sometimes this gets hard to see, so what I'll do is I'll turn on my mesh, and then I'll make it transparent so we can still kind of see it. So let's go back. I think I need to pick this too, just so it sees it. Yeah, so we're going to want this piece, and that piece, I believe. Yeah, there we go. I think that looks pretty good. All right, so we just continue the process. Let's do this surface next. Okay, so once we think we're done, we just keep doing this process over and over. Once we think we're done, we can just rotate around. Really, the best way is to look at the back and see if there's anything missing. And I think we look pretty good. I'm not worried about the outside edge. We're going to handle that separately. Let's go ahead and save one more time. Call this Demo 3. Again, I like to save in stages. at kind of major points. Okay, so now I want to start trying to fillet all this. Let's take a look now at our deviation. I'd say overall we look pretty good. Now we're going to put some radiuses in here, but the rest of it looks pretty good. Okay. All right, so we can hide the mesh again. All right, so first thing I'm going to do is sew all the surfaces. And what that does is just really cleans up all these intersection points, make sure they fit really well so that when we do the filleting, we just usually get better results with our fillets. And like a lot of things in Design X, there's lots of ways you can create fillets. Let's pick a few of these. Now, one of the things you can do is do this sample button here. And it's going to look at the underlying scan data and figure out kind of average the area underneath where we picked and come back with a recommended size based on the mesh. Now, I don't want to use that, so we can round this up. Let's go 25. It's always, we'll go a little bit bigger, or you can go a little bit smaller, just kind of depending on what you think you need. And, a lot of this is just picking it and trying to fit the data. Now, sometimes you can have issues with some of these corners, but let's see if we do tangent propagation. All right, let's go ahead and take this. And let's take a look here. I'm having trouble fitting that. Let's go in here and we'll do a separate one. Let's try, that looks, fit something in there a little bit bigger. And let's see how that looks. And a lot of this stuff's going to get trimmed off over in this corner. Let's hide our region groups, makes it easier to see. Take a look at our deviations. So I'd say overall we look pretty good. And, we can tweak this if we want. Filleting can be a challenge on stuff like this. Sometimes you got to do it in a few steps. Sometimes you got to use face fillets. Just, whatever you think you need to get it all nice and smooth. But I'd say, if you turn that on, overall it looks pretty good. All right, so now we're ready to start trimming this up a little bit around the edges. So I'm going to bring back the scan data, and I know I've got plenty of the surfaces are extended out plenty far, and then this just gets into a little bit of aesthetics. Now, there's a couple different ways we can do sketches. I'm going to do a 3D sketch, and I am going to do a spline, and I'm just going to kind of pick, and I'm just trying to make a smooth, kind of basically cutoff point. Okay, so there's where the top of the mat would be. And the way a 3D sketch works is where I pick here will be on the mesh, but in between it may not be. And that's okay. I don't need it to be on there. So I'm going to pick here and here. And again, this is where you kind of get into your design. So, do you want something that kind of comes up and then comes down here? This just gets into aesthetics. How far back are we going to come? Let's go to about right here. There's our trim line of where our mat's going to go. And you can come in and pull this and tug it and change it and delete it and try different things. That's the beauty of this. Maybe you want this a little farther back. Doesn't really matter. It's totally up to you. So now let's turn on our surface body, turn off our mesh, and we're going to go back to that trim surface command. Pick that as our tool. This is our target. Side we want to keep. And there we go. So there it's all trimmed up and looks pretty good. Now we're going to give it some thickness. So we're going to click Thicken Surface, pick this, and we'll go 3 millimeters. And we want to go in the up direction, which looks like that is, and we hit OK. So there we go. So now you can see what we have. So it looks pretty good. Now, one last thing. Let's hide the mesh. So when we drew those splines, we could have kind of made some corners in here, kind of smooth this out a little, but let's try a couple different things. First, let's try just the fillet command and, pick whatever size we want. Let's go 20. Give us a nice fillet there. Do the same on this one over here. That looks fine. Now, this one may be a little difficult because of the way this gets broken up with this fillet in here. Sometimes it has trouble. Oh, no, looks like it got it. Okay, perfect. So sometimes it just won't do those edges when you have that tangency coming in there. So again, we can continue to, trim this up any way we see fit. All right, for this next process, we're going to kind of speed through it because it's a little bit laborious, but I want to put our logo right in the center of the mat, and I don't have it yet in any kind of like 2D Illustrator or a 3D format. So what I'm doing is just segmenting an area on the mat. I'm bringing in a texture map, or basically a JPEG image of our new logo, and I'm just doing a 2D sketch over it. And then we'll turn this into 3D. But it's one nice thing is DesignX does allow you to bring in an image, put it on something, and in this case, we're going to just trace over it. All right, so creating the sketch for the logo is now done. You can see we have that sketch up here in space. We can hide the mesh. Let's bring back our mat, the solid body. And now we're going to extrude these sketches. We will go up to surface. I'm going to leave merge off for right now. You'll see why here in a minute. Let's repeat this command. Up to surface, click that guy. So up to surface will make it fit right on the curvature of this surface here. Now we want to trim this off. We don't want it that thick, obviously. But we could trim it to a plane, or we could offset a surface which would follow the curvature of this surface, which is what we're going to want to do. So we're going to come to surface offset, pick this. How far up do we want to go? We'll take 4 mils is fine. Let's go ahead now and hide the solid body for a minute and turn on the surfaces. Oops. We need to keep on our stuff there. So you can see it's poking through below. We'll use the cut command. Our tool entity will be the surface, and our target bodies will be these. And then we got to pick the side we want to keep, which will be those there. And then we hit OK. If we now hide that surface and bring back our solid. So might be hard to see, but now this will follow the contour of that mat. And we can now merge or Boolean them all together. And now we have that. Okay, so there's our logo on there in 3D. So let's go ahead and just add some other, kind of ribs or whatever. And this could be done the same way. If you had a picture of an existing mat, you could use that. We'll just do a few things. I'll just throw some stuff on here. This gets into more just style and what you want to do. All right, so next we're going to now just make a bunch of 2D sketches, kind of similar to what we did with the logo. And just for time purposes, we'll speed this up because, again, it gets quite repetitious, and we don't want this video to be hours long. But you can see what we're doing here. I'm just making 2D sketches on a plane and just playing with, some different things. I'm not a floor mat designer. So don't take this as the perfect way to design a mat, but it's the same process. It's really just defining some different sketches and whatever kind of design, style you want. And these are typically for traction or to kind of hold channels to kind of hold the mud in place. They do different things. These designs can actually get quite complex, and they sometimes do multiple kind of levels or layers to them. But you get the general idea. It's typical, CAD type 2D sketching, getting things the way you want, throwing radii or whatever it is you're going to use. So I'm using a variety of commands: the slot tool, the line tool, fillet tool, and then here I'm just copying and moving. But that's it. You just do that till you get everything the way you like. You can do different iterations until you get your final design. All right, so now that it's done, we will just do the projection down, the offset surface we already have. We're just going to trim everything to that and keep the side we want to keep and merge it all together. All right, so just to recap what we did, we 3D scanned the vehicle, brought that scan data here into Design X, created some different surface types, trimmed them all up, added in some fillets, trimmed the outside, and then from there, it's whatever you want to add on the inside. You can see here, we got creative. I'm not a floor mat designer by any stretch of the imagination. But again, once you have this shape, you've got a lot of freedom. Now, and these floor mats can get far more complex. I've seen, different fastening systems. Some of them have kind of different levels. But once you have the, the basic area surface, the whole footwell area, you really can do whatever you want. And the beauty with 3D scanning is, you're going to have a perfect fit. So it's a great application for 3D scanning and design. And in this case, we used Geomagic Design X.